first example, there are ways to solve this, but I'm just going to show you that one of the ways you can do this is by making the denominators the same. So what we could do is that we could look at these two, which are different than 2x. So what we could do is we could change this denominator so it's the same. So in order to make the denominator the same, we need to multiply the top and bottom by 2x, and then this one is super close. All we need to do is multiply the top and bottom by 2 over 2. Again, the reason we multiply the top and bottom is to make sure that we don't change the value of this. So this would become 8x over 2x plus 2 over 2x equals 10 over 2x. Okay, so at this time, because everything is over the same denominator, we know that logically speaking, 8x plus 2 is equal to 10, right? Logically speaking, since both of them, we're comparing the same sizes now, and we know the numerators, because of this equal sign, it means that this side is equal to this side, so the numerators are equal to each other. So mathematically, what we could do is we could just get rid of the denominators, or an even better way is just to multiply both sides by 2x over 1, 2x over 1, and then we just get rid of all the denominators, okay? So really, when you guys get rid of the denominators, you're really just multiplying by 2x to everything. Just make sure if anything is separated by a plus or minus, you have to distribute the 2x to everything. So this 2x actually gets rid of not only this one, but also this one, because you're distributing it to both terms here. And then we just cancel out. So 10 is equal to 8x plus 2, right? And then we just minus 2 on both sides. We get 8x is equal to 8. We divide by 8 on both sides. And then x equals 1. Okay, so what point do you have a question on? Okay, so do you get why we multiply by 2x? So we do so to get rid of the denominators, right? So we just want to cancel out the denominators, because all of them are over 2x, right? 8x over 2x, 2 over 2x, 10 over 2x. So in order to get rid of the denominators, we have to multiply everything, or every single term, by 2x. If we do that, it gets rid of all the denominators, and then all we're left with is the numerators, or the top. It's a good question. All right. Does anyone have any other questions about this one? So again, we try to get rid of the denominators just by multiplying by 2x. And again, all we're left with is just the top portion, or the numerator. Okay? Then we solve for x. We get x is equal to 1, and that's it. That's our... And if you just want to do one better, you could plug it in just to check, is my answer correct? And you would get, 4 plus 1 over 1 is equal to 10 divided by 2 times 1. I know you can't see this right now. And that would just be 5 is equal to 5, and that works. So, yeah. That's great. It's all good news. Okay, so in this case, the technique we use is to make sure all the denominators were the same, and then we got rid of the denominators, and then we solve for x. Okay. So in this method, the first one we did is we wanted to make sure to make all the denominators the same, so we're comparing the same size pieces, and then we solve for x. Okay, in our second example, we have 5 over 4 divided, or equals n minus 3 divided by n minus 4. So in this one, what we could do is we could multiply everything by the denominators already. And again, you could use multiple ways to solve this. So I'm just going to multiply everything by n minus 4 over 1, and I'm going to multiply everything by 4 over 1. So I'm going to multiply both sides by n minus 4 divided by 1, and I'm going to multiply both sides by 4 over 1 to get rid of the denominators. back out a little bit. So I can do this because I'm increasing both sides equally. So because I'm increasing both sides of the equations equally, the statement is still true, right? So now I could, on the left-hand side, because there's a 4 on top and there's a 4 on bottom, I'm left with 5n minus 20. I did 5 times n, 5 times negative 4. And then on this side, the n minus 4s cancel out, and I'm left with 4 times n, which is 4n, and then 4 times negative 3, which is negative 12. So again, for this portion, what I did is I tried to get rid of my denominators by first multiplying everything by all of my denominators. One of my denominators was n minus 4, so I multiplied by n minus 4 on both sides. One of my denominators was 4, so I multiplied everything by 4 on both sides. Okay. The next thing I would do is just solve for n. So I minus 4n on both sides, minus 4n. I plus 20 on both sides, I plus 20 on both sides, and I get n is equal to 8. N is equal to 8. So what I did is I moved all of my n's to the left side, and I moved all of my numbers just by themselves to the right-hand side, and I get n is equal to 8. So I can test this. So I have my original equation of 5/4, n minus 3, n minus 4, and then I do 5/4, and I plug in 8, 8 minus 3, 8 minus 4. So I plug this in, and then I get 5/4 is equal to 5/4. And it works. So again, if I plug in my solution and back to the original equation and it works, we're all good, right? Your solution works. Okay, so all of this is just, again, these first two examples are just kind of a review. I believe we've done these multiple times, whether in my class or some other class. So, yeah. Okay, does anyone need more time on this? Does anyone have any questions? Okay, on this second portion, and again, these are questions we saw yesterday, but I just want to solidify the things that we learned. On this one, you could see that one technique we could use is to get rid of the denominators by multiplying everything by x minus 3. And there's a 2, so we're going to multiply everything by 2. So we're going to multiply everything by x minus 3, and we're going to multiply everything by 2 over 1. Okay. If something is like this, where you see there's a plus in between, then we're going to multiply both the first fraction and the second fraction by whatever we're multiplying, okay? So again, if you're multiplying x minus 3 to the left-hand side, you're not only going to multiply the first fraction, but you're also going to multiply the second fraction. Okay? So for this one, we're going to do 4x times 2, because the x minus 3's cancel out for that one, so we're left with 8x. In this one, the 2's cancel out, but then you're going to be left with x times x minus 3, and I actually just leave it in that form. This one, the x minus 3's cancel out, and you're just left with 12 times 2. So we have 8x plus x squared minus 3x is equal to 24. And remember that when we're left in this scenario where we have an x squared and a negative, we have something x, we want to make sure we move everything to one side, and we want to make sure our x squared is positive so we can factor, okay? So again, if we have an x squared and we have other x's without x squared, we want to make sure we move everything to one side so we can factor it out, because you can't solve it normally, okay? So I minus 24 on this side, I minus 24. I can't combine negative 3x and negative 24, they're not like terms. But I can combine 8x and negative 3x, so it becomes x squared plus 5x minus 24 equals 0. So at this time, Now I can factor it out. Now I can factor. So now would be the perfect time to draw an x. Now you can draw an x. And then you can solve. You could say, well, negative 24 on top, 5 on the bottom. You want to think about two numbers when multiplied equals the top, but added together equals the bottom. Eight and negative 3, so 8 times negative 3 is negative 24. When added together equals 5. Looks like we have a winner here. So 8 and negative 3, x plus 8 times x minus 3 equals 0. So if either one of these parentheses equals 0, then again this statement is true, right? We have 0 times a number equals 0. That's true. So we can set x plus 8 equal to 0 or x minus 3 to equal 0, because if either one of these parentheses equals 0, the statement again is true. So x is equal to negative 8, x is equal to positive 3, because we subtract 8 on both sides, and we add 3 on both sides, we get x equals negative 8 or x equals 3. And so you might just box your answer and be like, okay, I'm done, right? But what you want to do, again, is you want to plug it into the original equation and check your answers. So, let's see here. Kind of need more room. Uh-oh. Paper. So, in this one, I'm just going to check my answer. So, I have 4x, x minus 3 plus x over 2 equals 12 over x minus 3. So let's first plug in 8. So we have 4 times 8 over 8 minus 3 plus 8 over 2 equals 12 over 8 minus 3. Wow, that's fun. So then we get 32 over 5 plus, I'm just going to write 4 equals, oh yeah. Did I write it down wrong? Oh yeah, negative 8, sorry. Negative 8. Negative. And 12 over negative 11. Is this negative 4? Oh, so this would be also negative 11, sorry. Oh, so this would be plus, sorry. This is super confusing. Okay. Sorry, let me rewrite this because this is so messy. So this would be negative 32 over negative 11 minus 4 equals negative 12 over 11. Okay. So this negative 32 over negative 11 turns to plus, and I want to make this the same like term. So 32 over 11 minus 44 over 11 equals negative 12 over 11. I subtract, I get negative 12 over 11 equals negative 12 over 11, and so that works. I know it's a really roundabout way to check, but it works, right? Okay, so we also want to try our other solution, and we get 4x, x minus 3 plus x over 2 equals 12x minus 3. And I'm just going to plug in these numbers here, and you get 4 times 3 over 3 minus 3 plus 3 over 2 equals 12, 3 minus 3. And I get 12 over 0 plus 3 over 2 equals 12 over 0. And now you can see that one of the solutions does not work, right? One of the solutions does not work. We get 12 over 0, which is an undefined answer, right? Undefined. And so what we discover here is that 3 is what we call an extraneous solution. And so you can go back to your original problem, and then you could cross out x equals 3 and be like, the only solution is actually x is equal to negative 8. So the only solution here is x is equal to negative 8. Okay. Question? Oh, yes. Okay. Let me bring it all back up. Do you need both? Yeah, let me just close it down. Okay, does anyone need more time for these problems? Does anyone have any more questions? Okay. So our last example that we're going to do together is just this last one right here. So this one is a little more simple. We can just see here they both have the same denominator. And in order to get rid of the denominator, we're just going to multiply everything by x plus 1 over 1. And we're going to multiply everything by x plus 1 over 1. And then they just cancel out, so we're just left with 3x is equal to 2x minus 1. We minus 2x on both sides, we get x is equal to negative 1. That's it. Okay. So you can see here what we did first is we multiplied everything by x plus 1 to get rid of the denominator. Then we just solved for x, and that was it. Question?
Do you have to multiply if it's the same and can you just get rid of it?
Technically that's what you're doing. If you do just get rid of it, I understand, but technically that's what you're doing. You're multiplying everything by x plus 1. I just want you to see mathematically what you're doing, and also logically, they just kind of make sense too. Okay, so before we say this is our answer, we just need to test it. So as per usual, we're just going to plug it in to our handy dandy equation. So we get 3 times negative 1 is negative 3, and then we get 0 on the bottom. We get negative 3 over 0. Which seems like it would be the correct answer. But again, if you get anything over 0, that's an undefined answer. That doesn't make sense. And so here, you actually have no solution. You have no solution. No solution. So what does this mean when you have no solution, but in this case it looks like you have a solution? What this means is that both graphs will intersect at one point. So normally they would intersect at the same point. However, because both of those graphs have a hole in them, they're literally going to meet at a point where they're both missing a section. And that section they're both missing is the place that they would intersect. But because they're missing both, they don't ever intersect. Okay? That's what it means, no solution. Okay, so for this one, you would just write no solution as your answer because you tested it, and that would be it.